Now that we have found the sample regression line, we have to look at what can we make out of the coefficients. So we have the fitted regression line here, and the beta naught hat is the intercept, and the beta 1 hat is the slope of the regression line. So beta naught is the value of the regression line when x equals to 0. Okay, so if we have the regression line here, the sample regression line with y here and x here, then beta naught hat is here when the x variable is 0. Okay, and it's important to notice that the intercept has the same units of measurement as the y variable. Okay, so important to notice that in some applications, this intercept has a meaningful economic interpretation. Okay, in some instances. For example, consider the case where price, the expected average price of a diamond is 15 plus 2,697 times the weight in of the diamond. So weight is the weight of the diamond, and the intercept measured in dollars is the predicted price of the diamond if the weight is 0. Okay. You haven't heard about a 0 weight diamond, of course, but in this case we can actually interpret the intercept as a logical measure. So we can interpret it as the fixed cost of the diamond. For example, the portion of costs which do not incur because of the weight, but incurs for all diamonds. Okay, so for example, the cost of a jewelry box, or the cost of just selling the diamond. Okay, and in other applications, the intercept has no real world meaning. So for example, we have a medical equation here. The expected average blood loss during an operation is 552 milliliters of blood minus 130 milliliters of blood times the height in meters. Okay, so this might be used as a estimate of how much blood the surgeons have to have, or the surgical team have to have in store in preparation for a certain operation. So what do we make of the intercept in this instance? Well, the 552 milliliters of blood loss, it's actually the expected average blood loss of a patient who has a weight of 0 kilos. So this is of course nonsensical. So it's better to think of the intercept in this occasion as a mathematical entity which helps you get a better fit to the data. And what do we make of the slope, the beta 1 hat? Well, there are two things we have to consider, and one is the change that this slope is the change in y beta 1 hat in the change in y given a 1 unit change in x. Okay, but you have to realize that this is just a mathematical association, okay? It's not causality in itself, because you could easily just rename these variables. So you have the x variable as the dependent variable and the y variable as the independent variable, okay? And you would get a regression line, and then you would get like x is causing y and y is causing x, just a matter of how you set up the problem. So you have to say that the intercept is the change in y associated with a 1 unit change in x. Okay, so this beta is the change in y, delta y, given 1 unit change in x. Okay, so the units of this slope is would be the units of y divided by the unit of x. So for example, if you look at the problem with estimating the salary, okay, then you would have years or euros. Sorry. You should actually have this is wrong because if you have the example, then you would have the salary, expected salary, equals an intercept, right, plus the slope times the education. Oh yeah, it's correct. So what you have is you have you have salary equals euros equals beta hat in euros plus the beta 1 hat is the slope. It would be euros divided by years times years. Okay, so if you look at this product, plus euros equals euros. Okay, so the units of beta 1 hat are those of y divided by those of x. So we have to say associated, that y is associated with a 1 unit change in x. That would be the slope, and we can only apply the interpretations of the slope and intercept over the range of values in our data that we can observe. For example, we have data here, right? And we fit a line. This is the y hat, this is the y, and this is the x. What if we have an x new here, and we would like to get the expected y for this x? Well, then we would have to extrapolate. We would have to extrapolate the data or the model to make that happen, right? But you see that we do not have data in this range of x, so it's really dangerous for us to do this kind of exercise, because we do not know if this linear relationship actually continues for other values of x. So, see you in the next video.